In this lesson, we're going to have a look at the organization blocks. And organization blocks are a special object in Tier Portal that's used to allow an entry point into your PLC program. And what I mean by that is without an OB block or organization block, nothing else can run. So you can have as many function blocks as you want loaded into your project, but if there isn't a overarching organization block, the PLC is not able to actually execute any of those function blocks. I'm going to go ahead and add our main OB1. And this is usually given to you automatically when you create a PLC. It will be called main and be designated as OB1, but I've deleted it just to show this process. And this is our main program cycle. And it is exactly as it sounds. It's the main program cycle. You must have one of these in your project in order to hang function blocks and other logic from it in order for the PLC to actually execute something. You can choose which language you want to write it in, although not all languages are available. And you can also give it titles, comments, version numbers, who wrote it, and some custom information down here for what family you want it to be a part of. And that's just a way of grouping objects together, and also a user defined ID. Once I go ahead and add an organization block, it will come through pretty empty. There are some inputs that come in here, which we don't really need to concern ourselves with right now, but they allow you to change some functionality around the block or to pick up some information about the block when it's executed. And that comes directly from the PLC as opposed to you passing anything into this object. You can still declare temporaries. So I can declare my own variable here and give it a type, but it's not retained between scans. And we'll come on to that later when I show you some examples of different types of variables. You can also define some constants, and those are things that cannot change in runtime. But the main reason for a organization block is so that you can grab something like our ladder example here and drag it in to your program. I've already got an instance for this, so I will select ladder DB, click OK. And now what will happen is when my PLC executes, it will come into this main OB and work its way down the networks. It'll hit this object here, go inside the object, and run the logic within, which is this switch input, asset output. You can write anything that you would like outside as well. We can write in this as if it was a function block. However, it's worth remembering that it has no instance data. So if you declare anything as temporaries, they won't be remembered the next time the PLC cycles. And again, this stuff will come with more experience and you'll have a better understanding as we come through the course. But organization blocks are not really the place to be writing complex logic. So let's have a look at other important OBs. We have our startup OB. And if I add this to the project, you'll see that it's almost identical as a normal cyclic OB. We just have some additional inputs or different inputs that we can use to manipulate this routine when it runs. If we just have a look at what Tier Portal says about the startup routine, a startup OB will execute one time when the operating mode of the PLC changes from stop to run. After completion, the main program cycle OB will begin executing. And basically what that means is because we have the startup OB in our project tree here, when the PLC is first changed from stop to run or on power up when it goes into run, it will always execute this block, this startup OB, before it falls back to the main OB1. And that's something that's important to know, that although there won't be any reference to the startup object, because you can't reference a organization block, it will run before this main. You don't have to have anything in here. You don't have to include it if you don't want to do anything, but the fact it exists, it changes the way your program behaves. Let's take a look at a cyclic interrupt. So that's here. And a cyclic interrupt is an OB that allows you to start or interrupt another OB at a very specific interval. And you can see the accuracy of the cyclic time here. You are asked to give a time that you want to interrupt in. And again, you can set different languages. And if I say OK, this will add this OB into our program blocks. And in the program blocks here, you can see that I have OB30, and this will interrupt main. And I'm not 100% sure if it'll interrupt the startup if it's set fast enough. I don't think it will, because I think startup has this sort of ultimate priority in terms of interrupting other things, except for diagnostic and fault blocks. But if I right click here and go to properties, we'll see that there are properties for each of these blocks as well. And come down to attributes. Here we can see a priority number. So right now we have a priority by default. This is something that TIA Portal set alongside the other objects that are in our project. It set a priority number of 13. So here it says the priority of the organization block, the CPU family used, and the type of organization block determine whether you can change the priority. So depending where you're using this, you might not be able to change it. The value 1 corresponds to the lowest priority. So right now this has, considering we only have 3 OBs in our project, quite a high priority. You can queue events as well. So if for whatever reason it couldn't execute, you can queue them. Right now, we've only got a value of 1 in here. No additional help on this, unfortunately. You can also report an event overflow into the diagnostic buffer, so you can tell the PLC, I actually missed doing this, in case it's doing something important, and then handle that appropriately. And here we have another place that we can set the cyclic time and also a phase offset. If we just have a look at how that corresponds to our main, coming in and having a look at attributes, we can see that this has a priority number of 1, and we can't change this because your main routine will always have the lowest priority. Because in a typical application where you don't want to interrupt or do anything special when something happens, there's no reason for it to have a higher priority than anything that's going to interrupt it. So there's not much to be configured for a main OB or a program cycle object. And again, in our startup block, you can see that this shares the same priority number, and that's because you can't execute the startup block at the same time as a program block. So maybe that can be interrupted. If I find any information, I will attach it under this video in this lesson. So look out for that if there's anything there. On top of these 3 here, I'm not going to add any more to the project. So here we have a time delay interrupt, which is somewhat similar to the cyclic. It's done on a specified delay time rather than a cyclic interrupt time. I don't think the accuracy of the time delay is quite as accurate as the cyclic. Can't remember, but there are slight differences between these two. We have a hardware interrupt, which is an important one. If something goes wrong with your hardware and things are configured correctly for your hardware, you can then call this organization block and it will react to the fact that you have a hardware issue. So here it says a hardware interrupt OB will interrupt cyclic program execution in reaction to a signal from a hardware event. The events must be defined in the properties of the module. So you do have to say at your hardware layer that you want to cause a hardware interrupt. In fact, I will just add this one quickly because it's worth showing you what sort of information comes in. So we would get a hardware identifier, which tells this object you were called by this hardware. We have a user structure identifier, which is another way of providing information about the reason why this has been called. A channel number, same sort of thing. An event type, and this event type will correspond, if you look at the help files for this, what type of event it was, and it'll be things like module unplugged or loss of 24 volts and things like that. And you also have a pointer address to information or data that the module is sending as well. For example, if you raise a module removed, the pointer address might contain some information relative to slot number, which chassis or rack the slot was removed from, and things like that. But you'd have to go and correspond to the help for that module in order to understand the information that's coming from the hardware interrupt. So this is a special block that can be called by many different things because there's many different types of hardware and contain different information every time. So here you do something like call a specified or special function block that you've written for a particular way of handling a type of module that is either likely to fail or does fail, and deal with that stuff accordingly. And if we have a look at some of the other ones, you have time error interrupt. Again, it interrupts a cyclic program. Any interrupt interrupts a cyclic program if the maximum cycle time has been exceeded. So if you start putting software into your system that takes a long time to execute or gets stuck in a tight loop that it can't get out of, and the cycle time of your PLC exceeds a value, then before your PLC goes into stop, or to prevent your PLC from going into stop, you can run your time error interrupts to handle that event accordingly. Diagnostic error interrupts. Again, if you have diagnostic errors that come from drives or things that have fallen off of networks and things like that, you can run this interrupt event to handle those accordingly. And then we've got some more specific ones. So pull or plug of modules. So if you remove or insert a module, you can run this, and that might be to reinitialize or to handle that errorness event while nothing's plugged in. A rack or station failure. Programming error. Now, this is an important one because during development, when you don't have everything, having a programming error OB placed in your project means that if any error occurs during program execution, it will run this instead of failing the PLC. I don't recommend leaving this one in your project, and it's important to understand why, because if you make an errorness edit on a live system and you have this programming error block in your project and downloaded to the PLC will not stop. It will just continue. So think of things like divide by zeros or accessing an array element that doesn't exist, putting an incorrect pointer into a memory area that doesn't exist. What usually happens is the PLC goes into stop and gives you a diagnostic message addressing this is why I stopped. If you have programming error in there, that doesn't happen. And the consequences of not stopping could be far worse than actually stopping. So it's something to think about. I like to have it during development because quite a lot of the time during development, I'm causing issues just by the fact that I'm trying to test or have a look at operations of my software whilst I'm developing. And it can become very annoying to constantly stop. Make it sound like I make loads of mistakes, but it's a good thing to have in there during development. And then I always remove it before sort of final checks and commissioning and things like that, just to make sure that if I do introduce anything, it's captured and there's a real that I can't miss it, basically. IO access error is an IO access error, something wrong with accessing module data. Time of day, things that happen at a specific time of day coming from the runtime, coming from the time clock of your PLC. And all of these MC ones are all motion control, so I'm not going to go through these. Motion control is quite a specific reason, but people who use motion control will understand the use cases of using these. And then we have synchronous cycle, which allows us to interrupt OBs to run subprograms that are synchronized against DP cycle, Profinet clock, things like that. So we can make sure that they run at the same time as other things. And then these three down here, I've never seen used, to be honest. But but they provide additional interrupts based on, so this one, for example, is if you modify the parameters at a slot or slave device, you can run an update. And that might be used for loading additional data into data blocks and things like that. But personally, I've never used these three down here. And that's it for organization blocks. So just a quick recap. The main ones that you're likely to use are startup, main, hardware interrupt, and cyclic interrupt. And then on top of that, you are probably going to use programming error at some point just to help you diagnose issues or to stop failures when you don't have certain equipment set up the right way. And then also remember that inside your OBs, you have a property for attributes and cyclic interrupt. Well, for this cyclic interrupt block, but you might have additional options depending on the block you're using, and they help you set priorities and control the way the object interrupts or executes. And then finally, just to remember that OBs are there to organize blocks. So organize calls to other blocks. They're not designed for you to write your actual project in.